This is chapter 109 out of the book, Wheels and Tires. This is something that every technician needs to know how to do. It's something that I didn't do a ton of early on in my career, and we started, the shop where I worked, we wanted to be able to do everything. We didn't want to have to send out a customer and say, oh, well, we don't do that. You're going to have to go over here, you go over there. This business is often about relationships. And once you build a relationship with the customer, then you don't want to have to send them someplace else. And a lot of times they don't want to go someplace else. And so wheel and tire work is pretty simple. You should know something about it. There's a lot of hand skill that goes with it in doing tire work. Nowadays, you see a lot of cars that have tire pressure monitoring systems in their tires. And so this is inside the wheel. And so this is one of the sensors that you'll see that's inside. You'll see the valve stem part poking out. But one of the things I want you to notice about this is that there's no wires that go to this. And so obviously then it's battery operated. And one of the things that I would want you to consider about even how technical the tire industry has even become is that if this is reporting wirelessly, then what module on the car do you think it reports to? Is there already a module or a computer or system on the car that already receives wireless signals? So hopefully you're already starting to connect the dots that this, from the factory on many systems, will actually report to the radio. And now the wheels are starting to turn, well, crap. A lot of people will change their factory radio for an aftermarket radio, and you're right. And the radio shops that are doing this right, the technology in radios and stereos is coming along to where some of them will be able to support the operation of these, but a lot of them, they're going to end up keeping your factory radio on the network for these sensors to report to, and they'll relocate it like into the trunk or under a seat or something like that, because if they get rid of the factory radio, then you get the little warning light in the dash that for your low tire that just blinks off constantly and drives you crazy. A lot of people will change out their wheels as well and not bring these sensors with it, and so then they'll have a set of 20-inch wheels on their vehicle, or 22s, 24s, whatever, and then they'll put just a regular valve stem in it and not bring this with it. I would bring the sensors with it off. They'll unscrew the mounting nut that holds them in, and all you do is put it in the new wheel and then tighten this back down. And so you can transfer them over even if you have aftermarket wheels and keep that system going. I prefer it. I like it. I find myself on my vehicles that have it, when I run something over in the road, kind of watching my tire pressures and seeing if I have one that's going low. It hasn't happened to me yet that I start seeing one that's at 36 and then 35 and then 34 and then know that I punctured it. But that's one of the benefits of it. And then for my wife and stuff too, a lot of the warning lights that come on nowadays in cars, customers will be the same. They don't pay attention to their dash, but a lot of the warning lights now will ding at you, like if your car's overheating or something, it doesn't just peg the needle, it's like ding, 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 like, hey, whoa, so that people will pay attention. So I wish they did that with check engine lights so that they couldn't just cover it up with a picture of their boyfriend or girlfriend or Virgin Mary or whatever, like you see on a lot of cars. It would force people into fixing them, but these systems have been required and mandated by the government, which brings up a point that I would like to make. And so in that regard, some of the cost that's incurred in operating these vehicles and in the cost of a new vehicle, a lot of that is incurred by government mandate. And so in the 90s, every car has to have an airbag, every car has to have ABS. Then they mandate certain emission standards and CAFE standards, and then they bring in and say, well, every car has to have a tire pressure monitoring system in 2007, and then by 2008 every car has to have controller area network. And so a lot of that cost that's incurred, not to mention the CAFE standards, which is corporate average fuel economy, so the fuel economy standards for these vehicles and emission standards, a lot of that necessitates the technology that we see in cars, and then it makes the cost of the car more expensive. And so in some cases, the manufacturers are meeting a standard that's imposed on them by the government. And so, not that I think this is a bad system, I think it's a good system. And the way that it does work is it's monitoring the tire pressure through a sensor that will report out to a module. Oftentimes it is the factory radio on the car. And so then it'll report the individual tire pressures. And so some of the things that we have to be aware of is even something as simple as doing a tire rotation. These sensor signals are unique, and so the one from this sensor would represent the right front. And so just because I move it around on the car and I do my tire rotation and now that tire's on the left rear, for a lot of manufacturers, unless I retrain the computer or perform a relearn for the tire pressure monitoring system, then it will, even though that tire is now on the left rear, that computer on the car would still identify it as the pressure that's reported for the right front. And so we end up, when we do rotations, if you want that information to be accurate, then you need to look up and see what the relearn procedure is. Some cars will relearn automatically just by driving. Other cars have to be forced to relearn. The system is not unlike many other systems on the car, that if the light comes on and it's on steady, the warning light, then you have a low tire. If it comes on and starts flashing at you, then you have a system malfunction. And so when people will say, well, I have a tire light that's on, that's the question that I often ask. Well, is it on steady or is it flashing at you? If it's flashing at you, then it has a malfunction. That's not unlike the check engine light. Some of you may not have experienced this, but in 1996 and newer vehicles, if the check engine light comes on, then you have a general emissions failure. And some of those will make the car run bad, but others can be emissions failures that don't affect the running condition of the vehicle. But if you have a check engine light that comes on, there's an emissions failure. But if you have a check engine light that comes on and it starts flashing at you or blinking at you, that means one thing. It means that you have a misfire, or a cylinder that is not making power on the power stroke, a misfire that could damage an expensive component in your exhaust called the catalytic converter. And so you should not continue to drive your car. You should get that fixed as quickly as possible if you ever have a check engine light that comes on that starts flashing, okay? So moving on to the information here for wheels and tires. Tire pressure monitoring system is part of that, and part of the technology of this is that these sensors are not cheap. They're $30 to $80 depending on the manufacturer. And so when we're doing tire work nowadays, there's a technique that you want to use to dodge these sensors so that we don't damage them during tire work. So we'll cover that sort of stuff out in the lab. But the purpose of the tire is to maintain friction between the tire and the road. And so this affects our handling of our car greatly. Ultimately, the tire, whether you're accelerating or stopping, is really the last line of defense to actually be able to stop your car. It puts traction on the ground. When you're accelerating, it transfers the traction and power to the ground, during accelerating and when you're stopping. And so your brake system, if you're on ice, your brake system can work perfectly fine, but if you don't have traction with the ground, you still don't stop your car and it would skid. It's an overlooked thing, safety item that myself, I take it seriously. I've got my wife and my kids that I love, and so I don't fear monger my customers like that, but this is honestly how I see it. That if I blow a tire or the car loses control because it can't get traction onto the ground and during wet weather, then you could get in an accident or you could lose control of the vehicle and wreck it and somebody could get hurt. And so it's something that I take seriously. To the point that if I see people driving around out in the public with unsafe tires, I at least let them know. There was a guy that I went to high school with not that long ago. I was in getting a haircut, and I saw him at the same Supercuts that I was at, and I noticed that the tread on his tire on his pickup was peeled off. So the little road alligators that you start to see, the tread was peeled off there. And then I saw he had a car seat in the passenger seat. I'm like, man. So I let him know, like, hey, did you know that your tire separated and peeling off on that right front? And he says, yeah, I knew that. He's like, I'm not worried about it. I'm like, golly, I would be. And so when I see things that are genuinely unsafe, I'll put it harder to the customers in that regard. And then I also especially have a heart for kids. And so if I see car seats in the car, I especially will say something and say it a little stronger. I view part of my job in the community and part of our job as technicians is to protect people and make sure that their vehicles are safe. And so if it's a genuine safety issue, speak up. So tires are going to affect handling as well, and so our ability to steer and control and things like that is all based on having traction with the ground. So the condition of the tires is one of the more important aspects of suspension, steering, alignment, braking as well, like I mentioned. So you need to know a little bit about tires to be able to do work like this in this industry. So some of the functions of the tire are going to be a shock absorber, absorb cushion. A lot of you guys have experienced this in this regard, that with a tire like this, the downforce on it is going to squish out based on the height of the sidewall. And if you have a lower profile tire, then you lose some of that cushioning ability to absorb shock as you hit bumps and dips and things in the road. Obviously, one of the jobs is to provide friction and traction with the road surface. Those of you that have modified your cars and have put an aftermarket set of wheels on them, and you put a set of low profile tires on there, you've noticed that the ride quality of that car will then suffer. That in the lower profile tire, the less sidewall here that it has, the less cushioning ability that car has. And so there is some reason the original, nowadays, getting a set of low profile tires is something that people do more often for looks, it seems like. But what do you think the original purpose of having a low profile tire and a stiff sidewall like that originally was, if it was not for looks? The original purpose of that was for performance, tire performance. And so you would see it on sports cars and things like that, because when they would handle better with that stiffer sidewall during cornering and things like that, and have less flex and less likelihood to have a blowout and things like that. My click. So in the notes that you have in the handout notes, there's at the very back, there's pictures of this diagram as well as a few others that you can reference back to as we go through this lecture. If you forget some of the parts of this tire and what they're called, then you can reference back to this diagram. The diagram here is just showing some of the different parts of the tire and the names that they have, the vocabulary that we use to talk about it. But the tread is the area that makes contact with the ground, and it's designed to provide traction for us and to be able to clear water. With the belting is the area right underneath that tread that just basically supports the tread, and so that we get better traction. Then the plies of the tire is kind of the carcass of the tire that gives it the framework that we attach everything else to and gives that tire its strength. The inner liner is another softer liner of rubber that is covering up the inside of our plies. And so it's softer rubber, and it's intended that if you were to get a puncture, that it would kind of close down and slow the leak so that the tire wouldn't just pop like a balloon and instantly deflate. The sidewall area of the tire is where you often see a lot of the labeling on the tire. What size is it? What is the speed rating, which some of you might not know the tires have, the load rating, and then recommended maximum pressure. The bead of the tire is a stiffer part that is where it contacts the wheel and seals up against the wheel. It'll have rubber laid over that. And then I cut a section of it out so you can actually see the bead, but it's typically a ring that's made out of steel. All the parts of the tire wrap and come to this bead, and then it's held in place by that bead. And the bead is a stiff area that when the tire is inflated, it's where we'll seat up against the wheel. The wheel itself is what the tire mounts to, and then we mount the wheel to a hub on the vehicle. A hub like this and then this is where that wheel would bolt up. You've got your bolt pattern there, and then this hub would bolt up to a knuckle that then all of our suspension components attach to. So we're going to cover these areas individually. So the tread area, we've got tread blocks that are going to be blocks of the tread that are designed to be perishable, that give us traction with the road. You've got ribs down the middle, grooves, sipes that come off of the side, and we've got different tread patterns for asphalt, for off-road applications where you've got mud and snow. You've got some different tread designs for different purposes. The purpose of this tread and having the grooves and sipes is to end up clearing water. And so when you hit a puddle of water or when it's raining, then you need to be able to clear the water off so that the tire can make contact with the ground, that it doesn't float across the ground, because if I don't have, or across on top of the water, because if I don't have traction with the ground, then you ultimately lose control of the vehicle. Which is why it's illegal to run a straight slick on like a racing tire, a slick on the public roads, because they don't have grooves and sipes on them to clear water. And so there are street legal slicks that will have a minimum amount of a tread pattern so that they can clear water, but a straight slick would be illegal to run on the road. And that's why they make a street legal slick, so that tire has at least some ability to clear water. Areas in the tread we measure with a tread depth gauge. It's just a simple tool that you can press outward and then set it down in the tread of the tire. And so if I were to do it to this tire, then I'd come down in this groove and I'd set it down, and then that one measures at that point, it measures about 5/30 seconds. Then if I come to the next groove next to it, that one is measuring at right about 3/30 seconds. Then when I come over here, we're at 2/30 seconds, and by the time I get to here, I'm basically at 1/32. And so this tire, in measuring it that way, you can see it with your eyes, but you can tell it has more tread on this side and it starts to lose tread as we go across that way. In general, like it says in the next slide, when we're measuring tire tread, the 2/30 seconds is the minimum tread depth that's considered safe. On a lot of tires, they'll put wear bars across there that right down the grooves, there'll be wear bars that when the wear bars are showing, you're at 2/30 seconds and you should replace the tires. This is, a lot of people will run them till there's no tread and they're completely bald, unfortunately, but this is one myself. If I have cracks in my sidewall and things like that for safety reasons, I'll replace them. If I see that I'm at 2/30 seconds or even close to it, I just go ahead and bite the bullet and I'll buy a set of tires just for safety reasons, because that's a big heavy vehicle going down the road. I want to make sure that I can control it. It's easy to see on this tire that the tread is worn down and it has more tread on one side and is bald on the other side. You can just see it with your eyes. The reality of the scenario like this is that at one point this tire was new and it had an even amount of tread all the way across, and this wear pattern started in this tire from the time it was new, and it started where it was wearing more on this edge and less on this edge. And so in measuring with a tread depth gauge on a newer set of tires, you can pick up on that just like I could pick up on it here when it's obvious, but I can pick up on it with a tread depth gauge before it's obvious. And so and the reason why that's important is because once a wear pattern starts in a tire like this, a bad wear pattern where it's going to wear out one edge faster than the other, that you cannot correct that wear pattern. I can go in and do an alignment or fix that worn part and align the wheels back to where it's square again to the road. This tire was likely riding on an edge like this. We call that camber, the tilting in and out like this. This is likely riding like that on an edge that caused this. Or the other thing that can cause it is called toe. where instead of being pointed straight down the road and rolling straight down the road, it's actually rolling on an angle and kind of dragging across the road sideways. And so that would cause wear on this edge if this tire was pointed out. If it was on this left side of the car, if it was pointed out, it would drag this inside edge. If it was on the right side of the car over here, it could be caused by the tire that's pointed in, because that would put this leading edge biting into the road first and scrubbing it off sideways. Now, like I was saying, once you start a wear pattern like that in a tire, then I can align it, but what's ultimately going to happen to that tire is, because it has less tread on one side than the other, then ultimately it's still going to wear out that one side first. Even once I square it up, now that I am wearing evenly across this tire, there's still less tread over here than there is here, and so this side is still going to wear out first. So once you start a bad wear pattern in a tire, it's going to finish out that way regardless of what you do after that. So that's an important point to understand. The tread in this tire is designed to be able to clear water. When you float across the top of the water and don't maintain traction with the road surface, then that's referred to as hydroplaning. You can lose control of your vehicle. Any damage to the tread itself, if it's in this area of the tread, then we can fix punctures, holes, anything in the tread with a patch or a plug. So any area of the tread itself we can fix, and there's a variety of different ways that we can fix these tires. One of which is just to put a patch. So a patch is just like a Band-Aid on the inside. So you don't fix the open wound of the tire itself when you put a patch on. The patches that I have, the patch that I have here is just a patch, and they're of different diameters. If it's a bigger hole, then you put a big patch. If it's a small hole, you put a small patch. The downside to putting a patch in a tire is that you don't fix the exposure to the environment from the outside tread area. You're only plugging the hole on the inside. What I would consider better than a patch, which is really easy to install, is just a rope plug. And so a rope plug does not have a patch on the inside, but what it does have is it plugs the hole from the outside all the way in. You can install rope plugs without ever dismounting the tire at all. They can be installed with the wheel still on the car. You ream out the hole, you install a rope plug through like a big needle, then you cram that down in the hole and pull the other end back out and clip off the excess, and that will seal the hole. It's a good thing to have in your car because you can fix a tire even out there while you're driving around on the road and keep it from going completely flat. The best way to repair a tire is with what's called a patch plug. And so this, you can see, has a certain diameter of plug that would fit through the hole, and then it also has a patch on the inside. And so to do this type of repair, you have to dismount the tire from the wheel. You grind off a flat surface on the inside because a lot of times there's irregular surface, little grooves that are on the inside. You grind that off with a cone type of buzz wheel, and then we prep the surface by cleaning it with a tire prep type of solution. It's probably primarily rubbing alcohol, and so get that surface free of oil. You put down glue. And start letting the glue dry. One of the steps that I skipped is there's a special reamer that you ream the hole out of that puncture to the size of the plug that you're gonna use. So you ream that hole out so that this plug will fit, and then buff off the surface, clean it with tire prep, then put your glue down, and then when the glue is dry, then you give it time to dry. Then you're gonna pull your plug through. This has a little protective plastic surface here that you peel off to keep the surface area clean of this patch. Pull the plug through, and then there's a little roller that kind of looks like a pizza roller or a pizza cutter, and you roll that out until you basically start peeling up the surface of the plastic that's on this. You roll it out flat and spread it out to the edges and get it seated as good as you can. Make sure it makes a nice clean contact. Then you clip off your excess that's protruding through your plug surface there, clip off your excess of that tail, flush with the tread. And then what I will do and a lot of other tire repairers will do is there's another product that's called inner liner sealer. And so it's kind of like a tar type of substance that stays somewhat soft, and I'll spread that over the inside of this patch. And what that is it'll just kind of cover up some sins. If you don't do a real good job of patching it, then if it starts to peel up, then it'll push that sealer in there and keep it from producing a leak. And so that would be the best way to patch a tire, is with a patch plug, because not only does it seal the inside, it seals the hole to where the environment can't infiltrate the hole and cause the layers of this tire to start to separate. Second to a patch plug, I would say is a rope plug, because at least it seals the hole from being protruded by the environment. And then the least quality type of tire repair would be an internal patch from the inside, just a patch by itself. So like I was saying as well, anywhere on the tread area we can fix a puncture. The closer it gets to what we would call the shoulder of the tire, so this area of the tire here, the closer we get to the shoulder starts to become a structural part of the tire. It's supporting the weight of the vehicle. And so if it gets to the shoulder, then what we typically don't repair it, because the patch would start to go up the sidewall of that tire, and then at that point it's not structural to be able to stay in place. You get to make your own judgment calls on this, on how close is too close. What I've advised some of my students in the past is I've told them, well, I would not put a patch plug there, but if you wanted to right down this shoulder area, as long as it's not on the edge, but if you wanted to down this shoulder area, you could put a rope plug and that would stay. We do not want to damage the structural integrity of this tire, and so anything on the side, like if you made some enemies in life and somebody hates you, right, and they go through and stab the sidewall of your tire, then we don't fix that. If you get tears in the bead, where the bead area, we don't fix that for safety reasons, because we need this area to seal so that we can support the weight of the vehicle and keep this tire inflated. So any area of the bead we don't fix, sidewall we don't fix, and really the shoulder area of the tire right on the edge where the sidewall meets the tread area, we also do not do repairs on. The only place that we do repairs is to the tread itself. So our sidewall is our area between the tread and our wheel. It often has a lot of the labeling information for the tire. Punctures on the sidewall we don't repair. The bead area of the tire is the foundation of the tire that everything really attaches to, and so it's typically the area where the tire meets the wheel and seals up against the rim area of that wheel. Copper or bronze coated steel, so they're typically a steel ring, like I showed you in on this tire where I've cut it out, where you can see all your body plies are wrapped around that bead, so it's part of our structure. Any damage to that bead area we don't fix. The body plies are our framework, or our carcass of our tire. It's what gives that tire its strength, and so anything that compromises the ability to support the weight of the vehicle on the sidewall area of our body plies, we do not fix. Located under your tread, all the areas of rubber around the sidewall, the body plies can be bias ply or radial. Most of your tires nowadays are going to be a radial tire. They do still make some bias ply tires. Typically they're cheaper tires that you'll see for trailers and things like that, but most of your passenger car vehicles, they are going to just be a radial ply. The belting is an area underneath the tread that with time, most of your tires nowadays are going to be a belted radial, that it supports the tread, allows to stabilize the tire, helps improve tread life and traction, better handling in that regard as well by having a belted tire. So this is kind of a view of the different tire constructions. Your bias is you're gonna have your plies running diagonally across that. That would be your bias ply tire. They do make a belted bias ply tire that would have belting areas right here on a bias ply construction of those plies. The radial tire is where they just go bead to bead and loop their plies over that way, and will have their belting underneath that to support the tire tread, better tire wear, better handling. It also will improve the rolling resistance of that tire, so better fuel economy and things like that as well. Like I say, trailer tires you may find like this is a cheaper way to construct a tire. One of the things ironically about this industry that I've read in several books, and I questioned whether it was true or not, is they will say often in a lot of the books that there's a lot of tires that are still made by hand. And I thought, that can't be true in this day and age, that they're making this stuff by hand. And it is true that a lot of your high volume tires are going to be machine made, but a lot of the lower volume tires are actually still handmade. And so that's kind of unreal to me that they still have a lot of handmade tires. But I asked at one of the seminars that I went to a few years back, they had a gentleman there that was from Goodyear Tire, and I kind of cornered him and asked him that question, and he said even from Goodyear, Continental, Michelin, some of our bigger tire brands, there's still a fair amount of them that are still made by hand. So inner liner and major splice. So inner liner is a pretty simple conversation. You're seeing the inner liner, and so this area here, you can see that it's not a real smooth surface on the inside, which explains why when we do a patch repair that we would have to grind this off flat. The inner liner is just a softer rubber that if you were to get a puncture in the tire, it slows down the leak. It's not going to plug it, but it will slow it down so that the tire doesn't instantly deflate, is the idea behind it. Then our major splice, when they do build these tires, like I was saying, whether it's machine built or by hand, the materials that they use will come in long strips. They form it in the shape that they want around that of that tire, right? The proper diameter on a mold. Well, then because it comes in a strip, there's obviously going to be seams where pieces of material line up. Obviously, they'll try to offset those seams so that they're not all in the same spot, so a tire couldn't just split apart like a clamshell. But they'll try to offset all these different seams as they build their plies and their belting and all of that, and even the tread material comes over the top. But there tends to be a place where the majority of the seams come together. And what that place is referred to as a major splice. And so you can see it relatively prominently on this tire, that you can see a seam that kind of runs diagonally across there. And so the reason why I bring this up is a little bit of understanding about the way these tires are constructed, is because some of your customers that are more observant, they may park their car someday, and as they're walking around, the sun will catch their tire just right, and they'll see that seam. And so when they see that seam, a lot of them will be concerned that there's a defect in their tire, that the tire's starting to separate. And so, like we've talked about, all these different layers that come on this tire as it's built and constructed, anytime that you compromise that tire and it gets damaged, there's a potential from a puncture or even from hitting potholes and things like that can start to tear the sections of that tire apart from being bonded together. Then there's a potential that with time and the heat that we get in Bakersfield and hot places in general, that those layers start to separate. And so then they'll get a bubble or kind of a wart in that tire that is higher than the rest of it if it bulges out. And so some of the customers, they may notice someday their major splice and bring it in for you to look at their tire. And one of the things that I want to tell you about that is that if that seam that you see is really consistent, like a straight line, like it was cut, and then it becomes a little more obvious that is a seam from the construction, and you can just tell them, no, that's the major splice, it's part of the tire construction, and explain a little bit of the information that I explained to you today. But if it's irregular, right, that it's not a straight line, you see it walking in an S-curve, or it's concave or convex or whatever, if it's not a straight line, then it is truly a separated part of that tire, and the tire would need to be replaced for that reason. A lot of customers as well will misunderstand a separated tire. What happens if I have a bulge in this tire where it has separated, then it sticks out higher than the rest of it. And so when you're reading that in the tread, then what will happen if they've been riding on that tire for a little while, then it will present itself as a low spot in the tread. Because it was higher, it would contact that spot more than the rest of it and wear the tread off more on that high spot from bulging. Eventually, it separates down, and the way you would notice it is as a low spot in the tread. And so as we're inspecting tires, like I mentioned in some of the previous lectures, when I have a car up in the air on the rack, I'll just take my hand and scribe it across in the dirt and then roll this tire on the while it's up in the air and inspect it. And one of the things I'm looking for is how the tread is wearing, looking for nails in the tire if I checked the air pressure and it was low. And then I also want to see how that tread is wearing, not just side to side, but I'm watching for any separated parts in the tire where I have low tread in a weird spot in the middle, or sometimes you'll see a section of tread like this on the edge that has low tread, and then as you roll the tire, the tread depth comes back. And so all of that would be an indication that the tire is defective and separated. And just to talk about what causes that, sometimes it's damage of some sort, either a puncture at some point that where a tire has been repaired, and you can usually see that, or sometimes it's the potholes that you hit. If you ever hit a really violent pothole, then that can flex this tire and bend it in, right, and overstress that tire when you hit that pothole like that, and then it can tear it and weaken that tire to where with time, heat, age of this tire, that it turns into a spot where it will separate. Want to talk a little bit about the tire size designations. There's a service description is the standard way that we see now. It's been standardized since the 90s, but it's what you're used to seeing. As an example, the P205/75R15. The numbers you may not recognize over here is the 92H. The 92 is your load rating and the H is your speed rating. And so if you weren't aware that tires are rated for a maximum speed, that might be good for some of you to know, because you may be driving your cars faster than what your tires are rated for, which is not a good idea. Service description, often referred to as well as a P-metric description, then that'll be located on your sidewall. High flotation tires are your off-road tires, and they're basically an off-road application. They're called high flotation because the design and construction of that tire is designed to be able to clear mud and snow, and to be a wider tire that would kind of help in floating across or staying stable on top of wet road surfaces or off-road surfaces that are muddy or icy and so forth. And so it keeps them from sinking down in that and getting stuck. High flotation style tire. In this one, a common description of that is your 33-1250 R15 LT. Then when you start hearing people talk about, well, I have 44s, I have blah, blah, blah. They're talking about a high flotation style of description. And we'll talk about that, but that's a typical off-road application. You'll also see some trailer tires and stuff like that that'll have this description as well. So in our typical service description or P-metric description, every one of those digits means something. The P is for a passenger car tire. The T would be a temporary tire. LT for light truck, and C for commercial in your like semi-truck and trailer, stuff like that. Then, and just to spend a little bit of time on this, what do you think a temporary tire is? A temporary tire is typically like your spare tire, especially if it's not a full-size spare. It's like your Space Saver spare, little donut spare. That'll have that description. Usually, although that's not always how people use them, but they're intended to they're not a real strong tire. They're a super cheaply made tire. They often have a very low speed rating, and they're intended to be a limited amount of miles on that tire. Like a lot of them will have a limitation of like, don't drive it more than 50 miles per hour and for more than 100 miles or things like that. And so If you guys have probably seen it too, but I've seen people with their donut spare on the freeway, which now that you know that they're usually not rated above 50 miles per hour, then that gets kind of freaky, right? And so those are the kind of people that when I see them on the freeway and they pass me going 80, I'm like, whoa, right? And I back off and like let them like get down the road and wreck somebody else. This area is the section width. The next one, that 215, is the section width. And so on our service description, it's the width of the tire this way, right? And it's in millimeters. And so that's our width, our section width of this tire in millimeters there. Then we get to the 80 part of that. That is your aspect ratio. An aspect ratio is the relationship of the width of the tire to the height of the sidewall. And so when an 80 series, they're saying that the height of this sidewall is 80% of the width. In that case, you have a variety of different aspect ratios. When you start talking about your low profile tires, then they have a very small aspect ratio, right? You can get even a 25 series is a relatively small aspect ratio, but you can get your 15 series and 10 series aspect ratio, where it's basically like spreading a rubber band over the top of the wheel, and they get harder to install the lower the aspect ratio is, and like I've mentioned already, the ride quality suffers because they become a much stiffer tire with that low aspect ratio. The R has to do with the type of construction of the plies. So if it's a radial, it'll be an R bias or a diagonal bias in that regard, bias belted, right? So in saying that too, you can understand why I would say that the majority of the tires that you're going to come across are going to be ones that are radial tire, because most of the time when you look at a tire description, you see an R right there. And I would venture to say probably the majority of you, if not all of you, have never seen one with a B or a D right there, because it's not a common thing on a passenger tire. Rim diameter. So the diameter of our rim in inches. It used to be 14s, 15s, 16s were common for a long time. Now a lot of cars are coming factory with 18 and 20s nowadays. 89 is your load rating there, and then your speed rating. We'll talk about each one of those. Want to come back to our aspect ratio here because it's a concept that I want to make sure that you solidify and you understand. But if we do it in inches, which is simple, if we say that this tire is 10 inches wide, and it was a 70 series tire, then it would be 7 inches tall on the sidewall there. So that would mean that sidewall is 70% of the width. Then a 60 series tire, we're saying the height of that sidewall is 60% of the width, so that would be 10 inches and 6. If it was a 50 series tire, then it's basically half the size of the width. So 10 inches here would be 5 inches here on that. And usually in our P metric or service description, you're going to see that aspect ratio just as the ratio. And then when you see your 205 or your 265 or whatever, that's the width of that tire in millimeters. And so you would have to calculate that. But an inch is a little easier to understand for most of us. So high flotation tire is this. If we're saying it's a 31, then as that tire stands on its side like this, then the height of that tire would be 31 inches tall. And so if you hear somebody that says they have 44s, then they're saying it is 44 inches tall. That's a pretty good sized tire in that regard. But a lot of your rednecks will boast about stuff like that. The section width is width in inches in our high flotation. So 10.5 is 10.5 inches wide. 12.5 is 12.5 inches wide. So the R is still our radial construction. It could be a B or D there. Rim size, and then LT would be for light truck. And then they get into load range, which has to do with the amount of weight that tire can carry. Looking at our load index for our P metric description, it's a code that represents something that you can look up. So in our one that we had on the first page, I think it was a 92. That means that each one of those tires could carry 1,389 pounds. So combined weight, right, they all could carry 1,389 pounds individually. So that's for each tire. Then when you get to your high flotation tires, they usually use the alphanumeric description here, or an alpha description there that is a code that represents a C would be a 6-ply. And then a D would be an 8, E-rated tires a 10-ply, F would be a 12-ply, And the understanding with this is that the more plies they put around, the further they build up the carcass of that tire, the stronger it then would become. And so a lot of times with that as well, then you'll see the tire pressure going up with on an E-rated tire, 80 psi max versus your C-rated tire, which usually you see 44 or 50, things like that. Then we get to the speed rating here. So our speed rating is also a code designation. And so this code designation is not alphabetical, although it looks like it would be. But if you're familiar, right, we're like QRSTUH. So not alphabetical, right? So this is something you would look up, and you would see that the one that we had was an H-rated tire. It's rated for a max of 130 miles per hour. The max end of this that we see is, you'll see the Y is rated for 186. The Z is open-ended. You'll see sometimes instead of a Z, a Y plus, right? And basically they're saying we can go fast, right, with a Y plus or a Z, right? It's above 186, but we're not really going to tell you how fast you can go, right? Go faster than that on your own risk, but this is as strong a tire as we can make. We're not going to be able to tell you exactly how fast. Now, one of the things I want to share with you this way, and it's probably not going to come through in the video, but you'll see it on plenty of the cars here at the college because they're all weather cracked. But on here, decent enough, like if this was what the tread looked like, I've got some tread, right? And if we look at our speed rating of this, it's a 97, that's our load rating. Speed rating is an S on here. So this is rated for 112 miles per hour. Now, would I want to go 112 miles per hour on this tire? That's what you had better ask yourself, because it's rated for 112 max new. This is not a new tire. If I look at this, the tread on this is all split and cracked and getting ready to peel off. And so you better consider that as well, that okay, your tire may be rated for 130 miles per hour, whatever, but if it's not in good shape, if it's aged and weather cracked and it's got punctures in it and stuff like that from repairs that have been made, you maybe don't want to go that fast on it either. So I should say this. When you rotate your tires, or you get a new set of tires, and say you only get two, right? Because you don't have an all-wheel drive, right? Say you are front-wheel drive or rear-wheel drive and you get a set of two. Where should your best tires go? So, a lot of people will think, well, I should put my best tires on the front. Or you'll hear people say, you put your best tires on the drive axle, all right? They'll say the front because the front is how we steer a car, right? They'll say the drive axle because you want the traction to the tire where your drive axle is. Now, safety-wise, I want you to understand this. And it's something you guys can all understand because you've seen it at least. I don't know anybody that doesn't watch Cops, right? So we watch Cops. I watch it. Don't like religiously watch it, but everybody's probably seen that show. And if you haven't, Google it. It's an interesting show. If you've ever seen the police do a pit maneuver, all right, then you'll notice that the police car, for the car that's trying to get away, the police car will hit the back end of the car that's trying to escape with the front end of their car, right? And which one spins out? The one that got hit in the back end. Equal collision, right? Equal collision, bam, they hit each other, bam. And so, but the one that loses traction to its rear wheels is the one that loses control. So what I want you to understand from that, it does not matter, front wheel drive or rear wheel drive, any of that doesn't matter. The axle in the back of every car is fixed. And where the axle is pointed will determine the direction that car goes, all right? And so if you lose traction to the rear wheels, you will lose control of your vehicle. And so for the pit maneuver is a perfect example of that. The police pit maneuver, it's physics, all right? And it's the engineering of these cars that when we align a car, we point the rear wheels down the center line of the car because that will determine the direction that vehicle heads. And we can steer it with our front tires, but only because the back tires have traction and are stable. So if you lose traction to the rear wheels, it doesn't matter what you do with the front wheels, all right? You're gonna have a hard time gathering it back up. So for that reason, it would be worse to lose or have a blowout on the rear of the vehicle than the front. Now, don't get me wrong. It's bad either way, all right? But it is worse to lose it to the rear because you're more likely to lose control of the vehicle if you lose traction to the rear of the vehicle than you are to the front. So if you ever watch circle track racing and stuff too, there's cars that make it around the track in a circle pretty quickly, and they'll have one of their front tires off the ground, all right? Because the rear is the one that's ultimately controlling the direction of that car.